Hi and welcome to the Neil Ashton podcast. In each episode, we explain some of the fascinating ways that science and engineering are changing the world around us. We talk to leading engineers from elite level sports like cycling and Formula One, to some of the world's top academics to understand how fluid dynamics, machine learning, supercomputing are bringing in a new era of discovery. We also hear some of their life stories, their career advice, and lessons they've learned on the way that I hope will be helpful to you too. So sit back and enjoy this episode. Hi, and welcome back to the Neil Ashton podcast. I thought I'd do something interesting today, which I was looking back at the previous episodes, and I saw that almost a year ago today, I did an episode called The Future of CFD, 5 Key Trends to Watch. It was season 2, episode 2. And I thought I will try and do another version of that and basically see a year on, was I right or was I wrong? So what I had as the 5 were the rise of GPUs in CFD, AI and machine learning, shift to cloud computing, digital certification, and I think I had a last one, which was mergers and acquisitions. Okay, now this was before I joined NVIDIA. I should just say. So obviously NVIDIA, creates GPUs. So the rise of GPUs in CFD. Can I answer that with being completely unbiased? Probably not. But it's true, basically. There has been an unbelievable rise in GPUs for CFD. I can say that even if I wasn't working for NVIDIA, I think people in the community know that to be the case. Has that accelerated in the past year? Yes, most definitely. It is, just the number one question. And again, I know I work for NVIDIA, so I'm going to say that, but it's true. I go to conferences and I see it without me even talking to them. They're showing slides saying, okay, it's 10 times faster on a GPU. I did not get involved in that study whatsoever. I'm just sat there listening to it. So it is absolutely the case. And as anything, it was slower at the beginning. People were like, okay, is this really true? Is this marketing? I think now there's been so many independent studies showing it that people are fully getting behind. And I think what's also made the difference is, one, the hardware's obviously keeps getting better and better. The pace of GPUs, because obviously AI has helped this, is far outpacing CPUs in terms of like generation on generation. Like the improvement that you get each generation is like this compared to CPUs, which is, a bit slower. So by moving to it, you keep getting better and better. So the reason to move has probably accelerated. I think there's been a healthy competition between different CFD companies, each seeing GPUs to be part of their differentiating thing. And that has created a sort of an acceleration, because as one vendor releases a GPU version, another one wants to make sure they also have one. So there's been a little bit of that, but for good reasons. It's not purely, just for the sake of it. It's because people are genuinely seeing a speed up, customers are liking it, and therefore they're doing it. And I think most interestingly, which is, I think, something I commented on, is there's a lot of startups now who are specifically focusing there on GPU native. And that has also definitely played a shift, because no surprise, if you write a code from scratch with a sort of software, hardware co-design, you're going to create something really good. And so because of those startups, they have shown in some ways the most optimum solution, and has really shown some very interesting performance. What I find more at a technical level interesting is where the whole unstructured implicit finite volume, which I guess was the industry standard, is that the most optimum numerical approach on GPUs? It could be, but because they're so much more powerful, and because of that, you can start to do more transient high fidelity LES. Then people are going, well, if I'm going to do an LES and I'm going to have to run lots of time steps and I've got this GPU, should I maybe now go back to explicit that previously wasn't maybe the optimum way of doing it, but now with the GPU it is? And then maybe could I do a warm modeled approach if I'm doing warm modeled LES? And does that mean I should maybe use an immersed boundary method because I don't need to resolve the wall? And so it's this interplay between the hardware and the software. It's creating some really interesting changes. And finally, one of the interesting was the high order side. I think high order, without going into too much of the technical details, there's some interesting stuff around like tensor cores, etc. So the whole high order thing is coming back in to play. So yeah, was my prediction of key trends for CFD correct, GPUs and CFD? I'd say yes. And is it still for 2025, 26? Definitely. It's only accelerating. And I think you'll find that it continues to accelerate whilst there is so much more learnings to be had in terms of optimal architectures. And there's like a crossover point when your compute gets higher, you can go to a different modeling paradigm. So for example, and not want to speak about this for too long, you've gone from, let's say, a wall resolved RANs, like a low Y plus RANs, where you wanted to resolve the wall and where you need a certain gridding strategy to be able to resolve the wall, to a wall modeled LES, where you say, oh, well, I don't need to resolve the wall because I'm modeling it. So maybe I can go to a different gridding paradigm and I can go to explicit. But if you go to the next stage, which is the wall resolved LES, then maybe you say, well, actually, now my gridding paradigm that was good for wall modeled LES may not be good for wall resolved LES, and maybe I need to do something slightly different. So it's interesting how these waves happen, and like I said, there's an interplay. So what I find most interesting is a year ago or 2 years ago, the most bold predictions was more towards hybrid RANs LES or wall modeled, and everyone said our wall resolved is too far away. I'm actually seeing now people be a bit bolder and say, well, you know what, with the latest GPUs, maybe a wall resolved LES is starting to become possible. And that's interesting. I think not for everyday applications, perhaps, but now that is coming up, some other stuff starts to get interesting, like just the sheer number of time steps you need to do. And yeah, so still important. Okay, AI machine learning. Well, yeah, that's clearly still a key trend. Has things moved up in the last year? Absolutely. I'd say one of the big breakthroughs I personally seen is probably a year ago, or a little bit before a year ago. One of the bottlenecks seemed to be volume prediction using AI surrogates. Stuff was coming out around like graph neural nets and being able to predict things, but all the examples were always on smaller cases. And one of the things that I did with some colleagues was to create that driver ML data set, which was really put out there as a data set to give realistically sized meshes and hopefully encourage people to see, right, can my method predict the entire volume? And a year, or certainly 2 years ago, it looked like not many people could do it. Everyone was just doing the surface, or maybe a few slices. And every time you saw something, in marketing online, it was always like the surface of the car or a slice of the car. What I found was breakthrough in the past year is various methods have come out. And I guess the most recent will be like transformers that seem to be the most computationally efficient for doing full volume predictions, as in training on a full volume and then doing an inference and being able to get a full volume out. I feel like that really accelerated the realization that some of these AI methods could give you back a flow field that was more similar to a traditional one. And that transition from like graphs to maybe neural operators and transformers, for me has been a really interesting one. And I'm certainly excited to see what happens in the next year. I think we'll continue to see new architectures, new evolution of AI. So that is definitely a trend that's continuing. And they're obviously linked, right? So if you have a faster solver, you can generate data more easily. You can then do the training. I think one of the big discussions now is on the right code architecture, like programming environment, because online training is definitely a hot topic. How can you take advantage of the transient nature of the flow? So at the moment, I'd say the state of the art is normally that you would just generate loads of data. And even if it was with a hybrid RANs or wall modeled, you'll just take a time average and dump that and train on that. But I think what's emerging now is this interesting, well, can I use some of the transient data that's being created anyway, dump them out at checkpoint and train on that. So I think the whole AI will continue and continue. The one thing that I would probably add to that AI bucket is the agentic AI side. So let's say you've got surrogates, that's in one bucket, and you've got LLMs for just general productivity gains and coding on the other. I put agentic AI somewhere in the middle, which is how can you have multiple agents working autonomously through some sort of master agent that can go off and do tasks for you. So instead of you having to manually click run this simulation or write a Python code that goes and runs, you instead give a text prompt saying, I would like to go and run this simulation with these parameters and please create me a report. And you'll have a workflow where an agent will interpret that request, will then go and, let's say, create a simulation setup for you, but crucially also then run the simulation, let's say in a HPC cluster, use a separate, agent, could be a surrogate model essentially, to go and run it or to do the meshing. And then another LLM maybe to do the analysis of the results. And the point being is that you have to kick that all off with a text prompt. That is the most cutting edge example. And that's what I feel is probably in the next 12 months will be the next big jump. And some startups are already doing it and some companies, but I feel that's probably one of the big next steps. I should add, by the way, for GPUs, I didn't mention, I think precision is a very interesting topic now. I think there's huge gains if CFD can use lower precision for obvious reasons. That there's so much flops in the lower precision because of AI generally only needs 4, 8, or 16. So it doesn't mean that you can't do 64 or 32, but if you can find a way to harness that power, then you can really unlock the next big acceleration. So the third one I had was the shift to cloud computing. Now, people who know me or listened to this before know that, I currently work for NVIDIA, but I used to work for Amazon Web Services, which is obviously a massive cloud computing company. And there is no doubt whatsoever that cloud computing has totally transformed the IT sector and the HPC sector. When I left AWS, I definitely saw an increasing momentum in people adopting the cloud because of the fact that they could essentially focus on the stuff that mattered to them and not on the sort of manual data center stuff. I still see that increasing, but probably the bit that maybe I was not brainwashed, because I'm joking aside a little bit, but I definitely am seeing still a more hybrid sense where on one hand, people are absolutely seeing the value of the cloud, through AWS or GCP or Microsoft or, all the cloud players. And by the way, there's an interesting angle now with all these neo clouds, like CoreWeave, etc., which is mainly, I guess, through the AI sort of GPU angle. But I'm still seeing a hybrid use that, there's still quite a lot of on-prem, there's cloud, and I still think there's a lot of room for improvements in the way to access cloud resources. I think SaaS, from a CFD point of view now, SaaS products are still not fully there. If you ask most people, are they doing it software as a service? No. They may use the cloud to have a cluster, but are they doing it in a true SaaS-like manner? I think that it's slower than I thought. People still seem to prefer, and there's good reasons that we don't have to get into, of having a local experience in that you're not just doing it through a web browser. And I think that's probably just decades of engineers being used to just SSHing in stuff and having running scripts. And it's something that you think would change, but it does seem remarkably stubborn. And so I definitely see the cloud continuing, but I'm still waiting for some company to come out there and really make it easy from a workflow point of view in like a true hybrid way, or to just simplify maybe the cloud experience. You still have to be quite an expert to do it. So I'm not changing that prediction. I'm just seeing that it seems to be a bit slower than I fully appreciated. Maybe in hindsight, that's because I was seeing all of the positive and success stories at AWS, and maybe I was not hearing the bits where people weren't, doing it. The fourth one I had was on digital certifications or higher fidelity methods. That, as I mentioned on the third topic, is definitely the case. You're having a huge increase of people going to high fidelity methods because of, number one, the fact that you can access the compute more easily. And that is definitely a topic that I think will continue to increase sector by sector. So the automotive has definitely pioneered that, and all have moved to higher fidelity methods. I think now, like I said, they're looking, how can I go from hybrid RANs to wall resolved LES? I think the aerospace sector is probably still trying to get from RANs, to hybrid RANs and wall model LES. And the work that, we did in the last high lift prediction workshop has definitely helped to push that forward. And there's some interesting work going on now to try and push it even further again to like wall resolved LES. But I see that continually, increasing. And now it's more around building up best practices and understanding of those methods, robustness, that everybody knows where they go wrong, where they go right. So it probably will take time for that, and for people to see the value, because it is undeniably more expensive to do it than lower fidelity. So I think there needs to be success stories that have been created. But I think probably one of the biggest challenges is transition. Certainly, I'm speaking more from a CFD and external aero point of view. But one of the challenges still with even going to wall model LES or hybrid RANs is transition modeling. And I feel that that's why the wall resolved LES is still very tempting, because it doesn't fully solve it, but it definitely helps to overcome some of those challenges. So I think that will continue, but I would look more at how do we make wall resolved LES type approaches more affordable. I am going to be doing an episode where we're going to talk more on the combustion side of things. I do realize that this podcast does tend to be a little bit focused on external aero. That's basically my background. So I am purposely trying to, diversify a little bit and make sure that we're covering other areas. And the final one was mergers and acquisitions and innovations. And this has definitely kept going. We have seen Ansys and Synopsys, so two big companies, merge. We have seen, Siemens, Altair, Cadence, Beta CAE. So this has kept going, and it was a trend that I predicted and is still true today, that there is so much interest in the computer-aided engineering and semiconductor businesses that, it's a growing business, really important, and big companies are realizing the value of acquiring or merging with others to, bring some of their technology in and speed up, their time. I think that will continue. I would say the prediction for next year, there's not many other big companies that can merge now. It has consolidated a little bit to Cadence, Siemens, and Synopsys. But where I do see there being definitely move is there's a lot of startups, and I'm sure that many of those startups will be acquired by some of these bigger companies, so they can start to really bring those to a more enterprise level and integrate it. So my prediction would be in the next 12 months that some of the startups that you may know of, I won't mention all their names, but the startups, I think you'll see some of them being acquired by high profile companies, just because that's a tried and tested route. When I spoke to the CTO of Ansys, and he openly admitted it. He said, that's what we do. We look for great startups. We may even, encourage them. And once they reach a certain level, we might acquire it. And that's a great way of developing new technology. Sometimes it's better to let a startup do it, who have a faster way of doing than let's say a big enterprise. But then they acquire them, they bring them, and that's how customers get to use them. So I think that will still continue. So where do I think things are going? Well, I think actually those 5 topics will still continue to be a thing for 25 and 26. And I'm excited to see how they accelerate. So hope that was interesting. I thought I'd keep it short. I know these podcasts tend to go to an hour or 2 hours, so I thought I'll keep this one short. And got a couple of really good guests coming up for the next 2 episodes. So look out for those. And for now, hope you enjoyed this episode.